So let's take a look at domain number 8 now, software development security, understanding, applying, and enforcing software security. So some of those key areas, according to that Mr. CIB that we look at, software development lifecycle, the SDLC, development environments, software security, and acquired software. So that software development lifecycle, a few things we need to touch on in there. Development methodologies, the maturity models, operation and maintenance, a little bit about change management, and an IPT, integrated product team. Now, the software development lifecycle, it provides a framework for the phases of a software development project, from defining the functional requirements all the way up to implementation. So we can think about what it is we need to do, plan that out, come up with an idea, design that out, and go ahead and push that out for implementation. Now, the model chosen should be based on the project that we're trying to meet, right? We have a project, we have an idea, we've been tasked to get something done. Hey, we need a product for this purpose, all right, or for this project. So we come together, we'll talk about dev teams here in a little bit. We can come together and develop something to make for this project. So concept, design, and then implementation. Now, some of those methodologies we need to refresh our memories on. We have the waterfall methodology. So that means each phase is going to be completed in sequence, one after the other, or consecutively, and contains a list of activities that must be performed before the next one starts. So it's not like we can, start at the beginning and then we know where we need to end up, so we go ahead and finish that, and then we try to figure out how to get that, and we piece it together. We don't break it up modularly or in different objects like object-oriented programming. We do this, we make sure this is done before we move on. Kind of like a waterfall, right? Water doesn't come from the top and then come to the bottom and then come back to the middle and come on down, right? It flows on down. Just like this methodology, it'll flow on down. We have the spiral method. Now this is each phase adds a risk assessment review, which is going to add some complexity to this a little bit, but it should also make it a stronger development methodology, right? Because now we're getting in and looking at risks that are associated in the different phases of our development. So schedules and estimated costs to complete are revised each time the risk assessment is performed. So hopefully this keeps us on budget a little closer, right? We're always accused in software development, well, you went over budget, you're taking too long. We said we needed it then, and now we don't have it. And this should help us, keep us in line a little bit more as far as, I guess keeping us in line is not the right way, keeping us on track of where we need to be. We had a concept, we had a plan. Let's make sure we're staying on that plan. Now, the decision as whether to continue or cancel the project is going to be made based on the results of those risk assessments. Like, well, you're 40% of the way through and you're way over budget, all right? Or the risks are just becoming too great. We're rushing too much. We're introducing too many vulnerabilities. We need to cancel this. Let's back up, regroup, and maybe revisit this project at a later time. So that's the spiral method. The rapid application development, RAD, all right? This is a form of rapid prototyping that requires strict time limits on each phase as we go through. It's going to rely on tools that enable quick development, hence the name, rapid application development. Now, this could be a disadvantage if decisions are, made so quickly, so rapidly that it leads to poor design. But what we're trying to do is get something out quickly, some type of prototyping. We can always come back and revisit it, maybe use a different methodology to solidify it, but we're trying to get it out quickly. Maybe we need to hit a specific deadline. That's why we have strict time limits. All right, we have to be here in 3 days. We have to be here in a week. We have to be here next month. And we have to stick to that plan. And then we also have something called agile development. Now, This has a description of development with short development iterations. This is supposed to help reduce risk. So like extreme programming, Agile requires highly skilled, small teams that are going to be designing, developing, and testing their work in small functional components. And they're also going to have continuous review, ensuring that the work is going as planned and everything is working correctly. We're staying on task, but at the same time, we're minimizing risk and we're working more effectively and we're getting where we need to be. It's working correctly in Agile development. Now we also have some maturity models, all right? The Software Engineering Institute has come out with a capability maturity model for software. It has 5 steps of maturity levels for development that I think we need to be familiar with for CISSP. So we have the initial level, the repeatable level, defined level, managed level, and the optimized level. So let's take a look at these a little closer. At the initial level, processes are disorganized, could be even chaotic. Now, success is likely to depend on individual efforts, not considered to be repeatable because processes would not be sufficiently defined and documented to allow them to be replicated. So we're just getting started. And as most software developers will tell you, it could be a little disorganized at first to where everybody gets their opinions out, everybody gets their ducks in a row, even if it's just you. I know if I sit down to write an application, it's a little chaotic at first. I got to gather my thoughts, get everything that I need before I can start moving forward. At the repeatable level, basic project management techniques are established, and the successes could be repeated, which is something that we want. We don't want to repeat failures, but if it's working, we want to continue to do it. Now, they're repeated because the requisite processes would have been made established, defined, and then documented. Document is important, and that's a step that we forget a lot of times. We need to make sure they're defined and documented, again, so we can go back and see them so we can continue to do anything successful and move forward. At the defined level, an organization has developed its own standard software process through greater attention to documentation, again, standardization, and integration. And then at the managed level, an organization is monitoring and controlling its own processes through data collection and analysis. So once we get it developed, we're going to manage it, right? At the managed level, we're going to be doing that monitoring and controlling through those data collections. And then once we collect enough data, we can go in and analyze the data to make sure it's doing what it's supposed to be doing. What we had initially, in the initial level, developed and came up with. And then the optimizing level. Processes are constantly being improved. So we can take the data that we have from the analysis, from the managed level, and see what needs to be improved. If anything, I'm sure there is. There's always room for improvement. So at the optimizing level, we're looking at those processes, constantly improved through monitoring feedback from those current processes, like I mentioned, and introducing innovative processes to better serve the organization's particular needs. So it's kind of like a planning stage, right? You can see how it trickles its way down. The initial level, right? Where processes were disorganized, chaotic, right? We're supposed to be getting processes together. Once we get the successful processes, we want to make sure we can repeat them. Then we want to define them with greater documentation, manage what it is that we're trying to do, and then optimize at the end because, again, we always want to get better. We want to make it better. Now, in operation and management, we're actually using software that has been developed. It also involves monitoring the performance of a system and ensuring the continuity of operations. Now, from our point of view, right, for a security professional's point of view, security standpoint, we're going to include testing, backup, and recovery procedures. It's extremely important. We don't want to just have a procedure in place that says, okay, we back up data every Saturday night with a full backup, incremental backups every other night, differential backup on Wednesday. Got a plan, okay? Test it. test backing up and recovery procedures, ensure proper controls for data and report handling, and ensure the effectiveness of our security processes. This is what we're about, right? As security professionals, we're always going to get in there and make sure that we have, effectiveness in our security processes that we set out in our policies. Here we're talking about operation and management. Now we also have something called change management. And you may have heard of this, you may be familiar with this, but the primary objective is to enable beneficial changes to be made with minimal disruptions to our IT services, software development, the organization as a whole. We want to make sure that changes are made in some type of controlled way. We don't want to just run out there and have changes made, especially when it comes to software development. We have to be able to have a process in place to make these changes or get these changes made for us. So some basic concepts when it comes to change management. First, you may do a request for change, an RFC. This is a formal request to change one or more of the project applications in there or the software development. May be preceded by a change proposal. All right, so you could have a proposal of this is what I think we ought to do. And then you can kind of get people on board, right? Well, it does sound pretty good. I'll back you up if you go, if you go do that. I think that would be a good change for our organization. So we could do a request for change after that. Now we have three types of change requests: a normal change, a standard change, and an emergency change. So a normal change, an addition, modification, elimination of anything that could have an effect on our IT services, on our software development, on our organization as a whole, right? Any type of change that we feel like we need to have made, normal change. A standard change is a pre-approved, low risk, and relatively common change, all right? So nothing way out there, but it is pre-approved, relatively common. In software development, it could be, oh, well, we need to change this process a little bit here, or let's change the way we do this right here, or maybe this process needs to come before this process. An emergency change introduced as soon as possible. We have a vulnerability right here. This needs to be changed right now. This needs to be fixed. We have a problem. Let's get a patch out. Let's get a shim out there. Let's get this fixed right now. You may have a change advisory board. All right, this is a body or group that meets to help the change manager or the team lead, the project manager when it comes to software, or the authority to assess, prioritize, and schedule the changes. So they're going to go through and think about, well, is this necessary? How much is this going to cost? How much is this going to set us back? Are we staying on time? We're meeting our time constraints, our time limits that we've set as our goal. We could have a post-implementation review. That's going to ask ourselves, was that change successful? We had your request change. All right. We understood it. We made the change. Now, did it fix what it is we thought we needed to fix? Was that change successful once we had it implemented? And then this is also a place where we can identify more opportunities for improvement. Again, we're always trying to move forward, have those improvements. So did this change offer more opportunities for improvement? You saw, well, this fixed this. Now, if we tweak this and change this a little bit now, because we did this one and it was successful, maybe we can make some other small changes over here. So in change management, we want to create and record the request for change, the RFC. Make sure they're registered, make sure we can identify them. Because if we have to go back and say, oh, well, there it is, we created it, we recorded it, all about the documentation, have to document what's going on. We can see where that change was, who asked for that change, date, time stamps, things like that. Review the RFC. Is it still logical? Right? Is it illogical, unfeasible, unnecessary, or incomplete? Or has it already been submitted? Yeah, you're working on a team and you see something and you have a great idea one night. You submit an RFC. Well, somebody else had that idea too. So maybe they submitted it before you, day before. So we'll review the RF and say, well, you know, Mark already submitted that. We're good. Assess and evaluate the change. Is the change necessary? Is it moving forward? Is it moving in the right direction? You know, people have ideas of what needs to be done, but sometimes pride, arrogance may get in the way. You feel like that is the right thing to do, but if you really step back and look at the big picture and you think, well, that's more self-serving than it is for the organization, maybe that's not the best idea. That's not the best change or implementation that we want to put inside of our project. And then, finally, hopefully, we authorize the change, build it out, and test it. We're go. We're good to go. Okay, your change, we understand it. It went through the board. It is necessary. We are moving forward. Nobody else has submitted this. It seems like a good idea. So let's go ahead and implement this change. Let's put this into our development and see if you are successful. So we can coordinate the change, build it, and test it. Now, technical groups have for building in this change, we'll have these groups together, our dev team that we're going to talk about here in a little bit. We'll authorize it and coordinate the change deployment. So authorizing it, we're going to prove that the result of the change was properly built and tested, and then have a formal report. Say, yes, we've done this, we're authorized, we're good to go. Coordinate the change. We can put some remediation procedures in place if we need to, because best laid plans, right? We've planned it. We've gone through the process of change management. We've had more eyes on it, more opinions on it. They've given the stamp of approval, but we implement it and something happens that was not intended. Have a remediation plan in place, just in case, right? It's always better to be safe than sorry. You know, you hope for the best and prepare for the worst kind of thing. So we'll review and close the change record. Everything has been changed. We close it out, and then we can finalize that change. Now, as long as it took me to explain this, it could happen just that fast. Because you may not have a board. If you're working on a team, software development team, a development team, all of this may be internal. You may come together as a team. There's 10 of you in there. And you decide on these changes. You can go through the project for the software development, and you may have an idea, and you suggest or recommend that change. And then everybody can have their input on that. And say, well, yes, it's this. And then somebody may be in charge of the budget. Somebody may be in charge of the timeline. And say, yeah, but if we implement this, we're going to go over our timeline. Is there any way we can do this on the next iteration of the software or next iteration of our project? Right? That happens all the time. If you can't meet your deadlines because of big changes maybe that have been suggested, and I'm not saying they're bad changes, but it may not be relevant at that time or feasible at that time to shove that change in there. Because again, we don't want to rush to code, right? That's not good coding practice, just to get another bells and whistle in there or some functionality. Now, if it's something critical, yeah, we may need to back up a second and add that in there. If it's one of those, emergency or important changes. But if it's a common change or something that's going to just add some functionality or whatnot, for example, it may be able to wait. Now, we could have an integrated product team, an IPT. So when it comes to product development, working in teams has proven to be more effective in overall for an organization. I found that more times than not. Now, usually those teams report to some type of team lead. So we just don't bring a bunch of peers together and say, here's your project. All right, somebody has to kind of give a little bit of guidance. Usually somebody is designated a team lead at that time. It may be a peer, but they're in charge of this particular project at this time. Not saying that they get a promotion and they're the boss, but they are leading that team. They are leading that project at that time. Because we do need somebody given some type of direction, and somebody, if we got half the team with one opinion and half the team with another, somebody to kind of bring them together, right? It's got to be somebody that pretty personable, technical as well, but somebody that can have good leadership skills. With the integrated product team, you get better input, you get multiple ideas, multiple opinions. You can help find and identify and resolve issues better, make sound and timely decisions. I don't know about the timely part as much, but they seem to lead to better decisions. You don't want the onus all on you when it comes to a project, especially if it's something critical to the organization, if it's important to the organization, if it's going to affect the bottom line in any way. I don't want to do it on my own, all right? I don't want, especially develop some software on my own for a project. I want to bring a product team together, all right? So we can share those ideas, share those opinions, fix any problems that are going on, and then move forward. Now, DevOps approach includes line of business, all right? Practitioners, executives could be in there as well. Partners, we could have suppliers. So this is not necessarily just a tech team, right? We're pulling a whole development team together here and getting a whole picture of what's going on. So the practice of operations and development engineers participating together in the entire service life cycle, from design, from the very beginning through development to production and support, right? So this is what DevOps is. The practice of operations and development engineers participating together. So it's kind of like a product team, right? It is a version of that where we're bringing these teams together to get things done more efficiently, more effectively. Now we have some vulnerabilities at this source code level that we need to be aware of as security professionals, security practitioners. Hard-coded credentials, bad idea. It's done. I've seen developers do it. I've done it myself in small applications. But they're usually backdoors, the credentials, username and passwords that a programmer or application developer will put into the code. So they can skip certain access controls that are in the code that are supposed to be there. But when I'm working on it, I want to be able to get to exactly where I need to get to. 10,000 lines into the code or whatever. So I can put in backdoors. Sometimes that gets pushed over into production because we don't get it taken out, right? It's fine when it's in a development stage, but by the time we roll that out to production and get it out to our customers, we need to get rid of all those hard-coded credentials. We don't want a backdoor sitting in there, all right? That's bad. That's a vulnerability because if somebody finds that backdoor, they have free access to our application now. That's a bad thing. Buffer overflows. This occurs when a programmer doesn't perform variable bounds checking. We talked about buffer overflows earlier in another domain. That's when we are utilizing memory space for our application, but we're putting too much information in there. All right, we're flowing out of the memory space, the buffer of where we're supposed to be running executing our application, running our files. So we get out of that memory space, and that could lead to denial of service attacks. It could lead to where we could run malicious code as well. SQL injections. Now this is the manipulation of a SQL server, a database server, through the web server, through the web application. So it's an attack on the database itself, but we're using the web application that we've developed as the catalyst to get through. Now this is not the database's fault. This happens to MySQL databases, Oracle databases, SQL, Microsoft databases. It happens to all databases, but it's on the programmer, it's on the software developer, not the database administrator or not the database itself. Input validation could help scrub this out where we're not susceptible to SQL injections. Don't allow characters like a single quote, a double quote, open bracket, close bracket, equal signs, things like that. If we're asking for a username and a password, do some input validation on that. Only allow certain character or a certain amount of characters. certain types of characters, only letters, no numbers, no special characters. So input validation would help us in that. A directory path traversal. What we're trying to do there, or what a malicious person's trying to do there, is escaping from the root of the web server. You may see a bunch of dot, dot, slash, dot, dot, slash, dot, dot, slash in a log. If you do, that could point to a directory transversal attack. Because what they're trying to do is get out of the root and get back to access the hard drive itself. They're trying to get out of the directory, the home directory of the web application that they're in, and maybe try to bounce out of that to get to like the C drive or a D drive or E drive, whatever drive that they can get to get some of that operating system data, because they're getting out of the web application. You could have cross-site scripting. You might see it XSS. This is an injection of a script into a web page. So let's say you have a text box, a comment box, any type of text box really, where I can type something in. I could put in, say, some simple JavaScript and run malicious code, possibly. I'm not saying I can. I could possibly run some malicious code in there. So I could put in an opening script tag, put in some JavaScript, like put in a simple alert box maybe, close off my JavaScript, and hit submit. Now, if I hit submit and that code pops up, if I get an alert box on the page, I know that web application is probably susceptible to a cross-site script. I could now get somebody to, I could probably steal somebody's cookies, get their session ID, do some session hijacking, and have a merry old time. So input validation there, again, would help us with that. There's some other things when it comes to coding that we could do using stored procedures, parameterized queries would help as well, also in SQL injections, by the way. So we could use some of that stuff to help mitigate these kinds of attacks. Cross-site request forgery. Don't get that confused with cross-site scripting, two different things. Cross-site request forgery is third-party submission of predictable content to a web application within the security context of an authenticated user. What we're trying to do there as a malicious attacker is get somebody else to attack a web server for us. So I may send them a malicious link, a phishing email, let's say, and they click on the link, and I could have that code that they've clicked on run against a different web server for me. So cross-site request forgery is an attack on the server. Cross-site scripting is an attack on the user's browser, on the end user's browser. Another problem we could run into is privilege escalation. And privilege escalation vulnerabilities, they allow an attacker access to be able to get additional resources. They may be able to actually do that, escalate their privileges. If they can compromise the system, they may be able to do a vertical escalation or a horizontal escalation. Vertical escalation, they're coming in as a regular user and they may be able to get administrative privileges. And now I have permissions to run programs, install programs, download programs, delete programs. If I wanted to come in as a regular user and try to get to another user's level, maybe they have a specific permission that you need or rights to specific files. You don't need administrative access. You just want permissions to some data over here. So maybe it's a horizontal. So you're going from a regular user to a regular user, but this regular user may have special permissions. Say maybe they're the HR administrator or the head of HR or whatever they're called, right? So they may have more permissions in HR. They're not a domain admin or anything like that, but they do have certain specific privileges that you want or that you need as a malicious user. Now, improper software configurations, poor coding practices, and testing practices often cause privilege escalation vulnerabilities. So we need to get in there and test your programs. Make sure you're doing proper coding. fuzz your applications, right? Just throw random data in there. See if you can break it. That's what you want to try to do. Now next, we'll continue on with Domain 8, starting with the refresher on databases.